this video, we will solve homogeneous linear differential equation with constant coefficient, specifically the auxiliary equation with distinct roots. So we're given by a problem of quantity d cubed minus 14d plus 8 times y is equals to 0. So as instructed by the book, we will assume if it's not specifically given what is the value of the independent variable, we will assume it is x. And the dependent variable will be y, so that will be dy over dx. So the first step in solving this problem is to transform it into an auxiliary equation. So that will be m cubed minus 14m plus 8 is equals to 0. So to get the roots of this equation, so we'll use asymptotic division. So to find the possible roots of this function, p over q. So getting the all possible roots of this equation is to assume that the first term will be q and 8 will be the p. So getting the multiples of 8, that will be positive negative 1, positive negative 2, positive negative 4, and positive negative 8. So using synthetic division, we will just jot down the values of the function. That will be 1. So 0, because we have no m squared, and minus 14, that is our m, plus 8, so that will be 8. So in this problem, I will use negative 4 as our divisor. So that will be bring down 1. So 1 times negative 4, that will be negative 4. So negative 4 plus 0, that will be negative 4. So negative 4 times negative 4, that will be positive 16. So negative 14 plus 16, that will be 2. So negative 4 times 2, that will be negative 8. 8 plus negative 8, that is 0. So as you can see here that we have a 0 answer. So that means that negative 4 is root of our equation. So that will be our first root, that will be m sub 1, that will be negative 4. So the answer of the synthetic division will be our next equation. So that will be m squared minus 4m plus 2 is equals to 0. So in this function, to get the roots of this, we will use the quadratic formula. That will be x is equals to negative b, positive negative square root of b squared minus 4ac over 2a. So plugging in the values of our quadratic equation, that will be negative. Our b is negative 4 plus, we will find first the root of the positive. So square root of b, that will be negative 4 squared, and our minus 4 times a, that is 1, times c, that is 2. So that is, and over 2a, our a is 1. So plugging this in our calculator, our x sub 1, that will be 2 plus square root of 2 is equals to, so that will be our m sub 2. So next is to get the negative value of our x in the quadratic formula. That will be x negative b, no, negative 4 or b. So minus square root of b squared, that will be negative 4 squared minus 4 times our a, that is 1, times 2, that over c, over 2a, that will be a 1. So plugging in the value to get our x sub 2 in our calculator, that will be 2 minus square root of 2. So that will be our m sub 3. Now that we got all our possible roots, so the answer of an auxiliary equation with distinct roots is written in the form of y is equals to c sub 1 e raised to m sub 1x plus c sub 2 a raised to 2m sub 2x plus c sub 3 a raised to m sub 3x. So plugging in the values of our roots, that will be c sub 1 e raised to m sub 1x, that will be negative 4x, plus c sub 2 e raised to our m2, that will be 2. 2 plus square root of 2x plus c sub 3 e raised to m sub 3x, that will be 2 minus square root of 2x. So this is our final answer. So problem number 19, so that will be quantity 4d to the power 4 plus 4d cubed minus 13d squared minus 7d plus 6 times y is equals to 0. Like before, we will assume that our x will be our independent variable and y will be our dependent variable. So that will be dy over dx. So the first step in solving this problem is to convert this into a auxiliary equation. So that will be 4m to the power 4 plus 4m to the power of 3 minus 13m squared minus 7m plus 6 is equals to 0. So to get the possible roots of this equation, we will assume that this first term will be equals to q and the last term will be is equals to. So all the possible roots of this function will be p over q, that will be equals to the multiples of 6 and the multiples of 4. So it will be positive negative 1, positive negative 2, positive negative 3, positive negative 6, all over positive negative 1, positive negative 2, positive negative 4. So using synthetic division to get our root, so we'll just write the values of our equation. That will be 4, 4, negative 13, negative 7, 6. So I will use negative 1. So that will be first step is to bring down 4. So 4 times negative 1, that will be negative 4. So negative 4 plus 4, that will be 0. So 0 times negative 1, that will be 0. So bring 0, negative 13 plus 0, that will be negative 13. So negative 13 times negative 1, that will be 13. So negative 7 plus 13, that will be 6. So 6 times 1 will be negative 6. So it will be 0. We got a 0 quotient in our solution. That means negative 1 is a root of our equation. So that will be m sub 1, our first root, is equals to negative 1. So just copying this. So that will be 4m squared. We don't have 4m cubed, I mean. So we don't have m squared because it's 0. So that will be 13m plus 6 is equals to 0. So to get the roots of this equation, we will use the P over Q formula. So that will be the multiples of 6, that will be positive negative 1, positive negative 2, positive negative 3, positive negative 6, all over positive negative 1, positive negative 2, positive negative 4. That will be the multiples of 4. In this part of the problem, I will use negative 2 as our divisor. Just copy the value of our equation, that is 4 negative or 0 because we have no m squared, so 0. And our m, that will be 13, negative 13 and 6, our constant. So bring down 4 times negative 2 will be negative 8. Negative 8 plus 0, that will be negative 8. So negative 8 times negative 2 will be 16. So 16 plus negative 13, that will be 3. So 3 times negative 2, that will be negative 6. So 6 plus negative 6 is equals to 0. So this means that negative 2 will be one of our roots. So that will be m sub 2 is equals to negative 2. 4m squared minus 8m plus 3 is equals to 0. So I will use quadratic formula to find the roots of this quadratic equation. So that will be x is equals to negative b, positive negative square root of b squared minus 4ac over 2a. So plugging in the values, so our b, so that will be negative 8. So negative times negative 8. So first we will get the positive root. So positive square root of b squared. So that will be negative 8 squared minus 4. Our a is 4 and our c is 3. All over 2, our a is 4. So plugging this in our calculator, that will be x sub 1, our first root. So plugging this in the calculator, we get 3 halves. So that will be equals to 3 halves. So that will be our m sub 3, our third root. So getting the negative value of our root, so that will be negative times quantity of negative 8 minus square root of negative b squared. So that will be negative 8 minus 4 times our a, that will be 4. Our c, that will be 3. So it will be all over 2 times 4, our a. So the value of this is 1/2. So that will be our m sub 4. So now that we got all our roots, we will write it in the form of auxiliary equation with distinct roots. So that will be written in y is equals to c sub 1 e raised to m sub 1x plus c sub 2 a raised to m sub 2x plus c sub 3 e raised to m sub 3x plus c sub 4 e raised to m sub 4x. So plugging in our values of our roots, so that will be c sub 1 e raised to m sub 1x, that will be negative 1, so that will be negative x, plus c sub 2 e raised to m sub 2x, so our m sub 2 is negative 2, so that will be e raised to negative 2x, plus c sub 3 e raised to m sub 3x, so that will be our third root, that will be 3 halves, so 3 halves x, plus c sub 4 e raised to our last root, that will be 1 half, so e raised to 1 half x. So this is our final answer.